Hello, and welcome to this video where we will continue our journey in learning quantum mechanics, and we will take further example in looking into the probabilistic system that we have seen in the last video, and we'll take an example of an classical system uh, to extend the concept, but which will also later on help you to draw parallels with the quantum system. So let's just start with the classical billiard ball example. What we have here, as you see, is four edges, and the the ball can be in any one of these edges. And the probability of finding the ball is represented by the matrices, which is stochastic in nature, but it is double stochastic. What does it mean? Is that both the row and the column are L1 normalized. So when you sum up the probability either on the row or on the column, it will turn out to be 1. Now, let's assume that we start with this initial condition where we have the balls in a vertical polarized state, that is, in the edges 1 and 4, and the probability, as we have indicated before, of finding in any one of these edges is 1 by 2. This is represented by the initial vector notification where you see half and half at the position 1 and 4, while 0 all other edges. If we now wants to transition, let's say taking a step, moving from x0 to x1, applying the initial probability matrices that we have, what you will see is that now we are moving from the vertically polarized position to a horizontally polarized position. That means the ball will shift from edges 1 and 4 to 2 and 3, with both 2 and the probability of finding the ball with both at 2 and 3 is both 1.5. Therefore, we are still maintaining our L1 normalized state. We can continue these steps further. For example, now applying the matrices again, you will see that we have now moved back to the vertical polarized state once again, which means we started from a vertical polarized state, we have taken a step, became horizontal, we have taken the step again, and it again becomes vertically polarized. With the probability of finding the ball is still not changing from 50%. That means 1.5 and 1.5. And this is represented by the state of vector x2, which is now been obtained by applying the matrix on the vector x1. If you continue to do this, you will end up finding this, the balls uh, moving between vertically and horizontally polarized states. So it will oscillate between these two, and it is quite easy to prove mathematically, as you can see on the screen. But what does this example serve us? It says that there is operator switch between horizontal and vertical polarization. There is 50-50% chance, so the L1 normalized state is not being lost. But this particular example will serve us to now look into the quantum case of billiard ball, and then it will help us to differentiate between how classical mechanics is differentiating from quantum mechanics. So let's stop here. I hope to see you in the next video. Thank you very much and keep learning.